g of x plus the log parentheses x plus 3 minus 1.
What do we want to do?
If you use the transformation in this graph,
Right. So what is the base function here? The base function. Ah, log. Of course, that's the base function. Then the first transformation on log x. Log x plus 3. What does this do when I change x into x plus 3? Indeed. Left 3. And I can also determine this from the domain. What do you have to write to find the domain of this function? We have to write something. Dictate it and I'll write it. What is a domain? How do I find the domain of this function? You will be asked to determine the domain. So yes, I have to write x plus 3 must be greater than 0, so x greater than negative 3. Indeed. Very good. Domain is, oops, negative 3 to infinity. Perfect. And now final transformation. Exactly. Log x plus 3 minus 1, down 1. Indeed. Very good. Well done. Now, there is a catch with this function. First of all, is it increasing on all its domain or decreasing on all its domain? Log x. Increasing because the base is how much? Look at the key in the calculator and tell me what is the base of log. 10. Very good. And it must cross at this point. What is this point? A pure log function will always cross here even if it's decreasing or increasing. 1, 0. Perfect. So now I have to shift it to the left. But remember, this function has a vertical asymptote. What do I have to shift first? The asymptote. First, I have to shift the asymptote from x equals 0 to x equals negative 3. So now please give me, where does this point go? Good. So from this point, where? Very good. Awesome. So this is the graph of log x plus 3. And now you told me to do what? You said shift this graph down 1. So where does my marker go? From negative 2, 0 to which point? Just read the point. Negative 2. Exactly. Indeed. So here's the graph. So this is log x plus 3 minus 1. Indeed.
looks so simple, it's not.
Say it again.
It looks so simple, but it's not.
If you just think for a minute, it will be simple. Okay, next problem. Let's not waste time. Anything else?
Why?
Any problem?
I got one.
Yes, please.
Y is greater than or equal to x squared subtract 49. X subtract y is greater than or equal to negative 7.
Perfect. Very good. This is a system of nonlinear inequalities. This is nonlinear, and this is linear, but we assume, we have to call this a nonlinear system. Good. So first we start with writing the equation. Why? Because I have to graph the equation. I'm not changing the inequality into an equation. I have to graph the equation, so I have to write it first. We've seen this so many times. This is probably coming in your dreams now. So what function is this, and how do I graph it? Yes, it is a parabola. And where does it go? Down 49. Where will it cross the x-axis? I need those points. No problem. So I'm going to say y equals 0. X squared minus 49 equals 0. I know how to solve this. What do I do? Yes. Indeed, I take the square root, x equals plus or minus 7. So then I know that this parabola will cross at 7 and negative 7, and it will also cross at negative 49. So my scale is off, of course. Do I graph it as a solid curve? Correct. So this is the parabola. Y equals x squared minus 49. This is not the inequality. I realize that the parabola divides the plane into two parts, the inner part, because it goes forever, the inner part, and the outer part. I'm going to pick the easiest point to work with, which is 0, 0. Is 0 greater than or equal to negative 49? If you say yes, I will shade in the inside. If you say no, that's false, then I will shade in the outside. The inside, indeed. Points on the curve and inside, all these, everything inside represents y greater than or equal to x squared minus 49. This is the inequality, not the curve. So please do not make that error. Okay, I will repeat the same steps for the other one. For x minus 7 equals negative 7. X minus y equals negative 7. When x is 0, how much is y? Very good. So 0, 7. When y is 0, how much is x? So negative 7, 0. So 0, 7, I'm going to say this. Negative 7, 0, I'm going to say this. Solid line or not? Good. Very good. On the line, I write x minus y equals negative 7. It divides the plane into two regions. I will pick this and check the bottom region. 0, 0. 0 greater than or equal to negative 7. If you say yes, I'll shade in the bottom. If you say no, I will have to shade in the opposite. You will say yes. Correct. And I will say yes too. So this is x minus y greater than or equal to negative 7. Now, if these two regions do not overlap, there is no solution. If they do overlap, there is solution. Do they? Yes, they do. Points on this line, points on the curve, and everything in between. So if you want to solve the system, you will pick a point anywhere inside or on the perimeter. Because all those points will verify both at the same time. If you pick anywhere else, you will either hit a point that does not verify either, or you will pick a point that verifies one or the other. But that's not the purpose of the system. The system is asking us to find the solution that works in both, that complies with both conditions. Solutions that comply with both conditions are in the yellow region, including points on the circumference or the perimeter. Is this clear? Yes, please.
Is it a rule that every time we have to, as you say 0, 0? That's what I get it. I get it very confused. Is it a rule?
Use the point you like. You can use any point you like. If you would like to use this point up here, 100, 100, you can.
And what are we using? You just using
Any point. Use any point you want. If you want to use this point 10,000, 0, it's fine. It doesn't matter. Any point anywhere. But why? Because this is the easiest to work with. I don't even have to calculate anything. But there is a catch. Very good question. If the line passes through it, I can no longer use it. I have to come up with another point. So if this line were like this, I would have used this point, negative, positive 2, negative 2. But since it doesn't pass through the origin, I'm going to use the easiest point to work with. But again, it doesn't matter which point you pick, but you have to remember where you picked it from and which region you are checking. Because if you pick from this area, if you pick from here, then you're checking the bottom region. If you pick from here, you're checking the upper region. So as long as you remember that, it doesn't matter which point you use. Very good question, actually. Next question. Anything else you want? Any problem, anything? Anything else? Sure. I mean, finding the x and y intercepts, is that, this should always be the case. We always look for the x and y intercepts. So that's all we did. We looked for the x and y intercepts. And we graphed accordingly. If it's a parabola, we graph the parabola. If it's a line, we graph the line. Next problem, next question, anything you want.
Find the length and width of a rectangle.
Yes?
Its perimeter, this is number 21.
Okay.
Its perimeter is 34 feet. And whose area is 60 square feet.
Very good. So of course we have x and y. So let's come up with an equation for the perimeter and then come up with an equation for the area. And then we will have a system to solve. Very good, awesome. 2x plus 2y equals 34, which will immediately change into x plus y equals 17. And what about the other one? Very good. Perfect, awesome. So of course from here I'm going to solve, let's say, for x. There is no other way. The variables are not the same. I cannot use elimination. So I will replace x by 60 over y plus y equals 17. Now I have to remember what to do next and what type of equation is it. We know so many different equations. We know exponential, log, linear, quadratic, radical, quadratic in form, absolute value, rational. What type is it? Once I identify it, chances are high that I will be able to solve it correctly and know what to do next. So that's why it's important to identify it. Say it again. Perfect, because it has variable in the denominator. Very good. So I recommend move 17. And then what we have to do is, obviously, yes, which is, we find the least common denominator, LCD. What is it? Very good. So then this one needs a y and this one needs a y because they're over 1. So this is over 1 and this is over 1. So can anyone dictate the numerator? Yes? Very good. Yes? Awesome. Yes? Awesome. And now I'm going to give you a little hint. What does that mean? Yes, yes, yes.
Am I right? Could I be right at that point where you have 60y plus y equals 7? Could I be right to multiply? I mean, if I want to do it, can I just multiply 12 by y? It's possible.
You mean 12?
Multiply y on the side. Just multiply 12 by y.
You mean of this one?
Yes.
So you want to multiply everything by y?
Yes.
That's fine. Yes. So you will say 60 plus y squared equals 17y. This is exactly what I'm going to get now. Yes, of course.
Okay.
However, if this method is okay here, but if the equation is more complex, multiplying like this could, I shouldn't say would, could make it more difficult. I'm not saying it's the only method, I'm not saying it's the best. Use common sense and, adjust depending on the problem. That's fine. So yes, so we are going to cross multiply. I think I heard somebody say that. So y squared minus 17y plus 60 must be 0. So we are going to get the same thing, right? So 60 is here, y squared is here, negative 17y. And if you have 17y here, you're going to bring it to the other side, it will be negative. So it doesn't matter. So if we cannot factor in a blink, we will be using the quadratic formula. But 60 is not a difficult number to work with, right? So 60 is 6 times 10. 2 times 2 times 3 times 5. So it's 12 and 5. I agree. 12 and 5. Perfect. So y minus 12, y minus 5. So we have two options, 12 and 5. But that's not good enough because I have to find the x. But that's okay because it's right here. If y is 12, then x is 5. If y is 5, then x is 12. So basically, there are two options, but they're basically the same, right? If one is 12, the other one is 5. If one is 5, the other one is 12. So 5, 12, or 12, 5. And yes, I recommend go back and check in the original problem. So 2 times 5 plus 2 times 12 should be 34. And of course, 12 times 5 or 5 times 12 is 60 for sure. Very good problem. Yes, please.
So,
Reggie?
would you have to do all that? Because if you think about it.
I don't want to think about it. I have to show a method.
Oh, okay. It gives you the perimeter and area.
Yeah, the guessing method may work, but it may not work in all situations, and I have to show a method. Yes. Yeah. I'm always hoping that all my students will continue to a 4-year college or university. And I have to say that I taught at the MBC for more than 10 years, and I could not allow my students, that's a law, no graphing calculator, not even a watch calculator. You're too young to remember those. So nothing, no calculator. So you will not be able to do anything. So most universities ban calculators. They're not allowed.
Oh, why?
Because they expect our students to understand what they're doing, not just punch in numbers in the graphing calculator. That's not knowledge. Anyone can punch in numbers. Even I can teach a 5-year-old to punch in a function. What does that mean? Nothing.
But if you don't know how to form the function, you don't know where you have to correct.
But many students punch in a function and copy the graph without even thinking that whether the graph is correct or not. So, good. Next problem. Anything else? Yes, please.
X plus 1 equals negative 11, and then x minus 3 and parentheses squared. The whole thing squared. Plus y plus 6 parentheses equals 34.
We did this problem last time. If you want, we can do it again.
Yeah, can we do it again?
Yes, of
Or
course.
we can change it?
No, that's fine. We can choose another. You want me to choose another, or we
It's
can?
up to you.
No, if you don't remember this, it's fine too. I mean, it doesn't matter. Okay, so obviously we cannot eliminate. These are not the same variables, right? So my only chance is to substitute. It doesn't matter what I substitute for, x or y. So let's say x equals negative y minus 11. I'm going to put this in here. So then I have a negative y minus 14 squared plus y plus 6 squared equals 34. Is this okay so far?
Yes.
We can't eliminate, right? Because the first equation has x and y, the second equation has a lot more, x squared and y. And is this okay so far? Yes? Okay, very good. So now the equation is quadratic. I will not have any difficulties solving it. I will get two y values, right? I square, I will get two y values, and then go back and find two x values. Good. So now, when both quantities are negative, just for your information, you can write this, correct? And when you square that, you still get y plus 14. So the point I'm making is, if both terms are negative, you should think of squaring this. You don't make any mistake if you don't think in those terms, but you have to make sure that all terms are positive. They will be positive. So how many terms do I write when I square binomial? Say it again. Louder for everyone to hear. Thank you. This was the first thing we did this semester, the first day. The first day, right? So if I see two terms, I will cross out the problem and put 0, because I will have tears coming down my cheeks. Okay, so please remember, yes, a binomial squared is 3 terms. Perfect. So the first term squared plus 2 times the first times the second plus the second term squared, whatever that is, we'll check in a moment. The same thing for the other one, right? Plus y squared plus 2 times the first times the second plus 36 minus 34 equals 0. So how much is 14 squared? Yes, 196. So then y squared plus y squared is 2y squared. Then we have these, so plus 40y. And what else is here? So we have 196 from here, and then this is plus 2, correct? So plus 198 equals 0. Then obviously I can divide both sides by 2, and I should always. And then I have y squared plus 20y equal, plus 99 equals 0. Again, 99, although it appears to be a difficult number to work with, well, 99 is what? It's 9 times 11, or 3 times 3 times 11. And I need to come up with a 20. It's not a big deal, right? So what do I have? Y plus 9, y plus 11. So I have y equals negative 9 and y equals negative 11, which is good. But I have to come back to x. So let me write x here. X equals negative y minus 11. And we are given y, we determined y equals negative 9. And I put it inside, and I get x equals negative 2. Because negative 9 with minus in front will be positive 9. Minus 11 is negative 2. And then when y equals negative 11, I will get x equals 0. So there are two options, negative 2, negative 9, and 0, negative 11. Is this okay?
Yes.
And yes, I have to go back and check. I have to make sure that they work. Good. Next question. Anything else? I'm not sure what number 2 is all about. E to x minus 2 plus 1. Let's take a look. E to x minus 2 plus 1. So we have this function, and we're asked to graph it using transformations. What is the base function? Very good, e to the x. What is the first transformation? Very good. Where do we shift this graph? Not up and not left. Right. 2. And then number 2. e to x minus 2 plus 1, up 1 indeed. Good. Now, is this an increasing function or a decreasing function on all its domain? Remember, this is exponential. It's not log. Increasing on all its domain or decreasing on all its domain? If the base is greater than 1, it has to be increasing. If the base is less than 1, the function will be decreasing. Is e greater than 1 or lower than 1? Of course. So here's the graph. Where does e to the x cross the y-axis always if it's a pure exponential?
Can you say that again? I just don't understand what
Yes, so this is an increasing function on all its domain. It's exponential. It will always cross the y-axis at 1, 0, 1. The function with transformations will not. But the pure exponential function will always cross at that point. Then you told me to move it, shift it to the right. Give me the marker. Tell me, where does it go? To which point? From 0, 1 to which point? 2, 1. Awesome. Here it is, 2, 1. So this is e to x minus 2. Perfect. And now you said, but there is a horizontal asymptote y equals 0. I have to shift the asymptote first. Where does it go? If I shift the graph 10 up, it will go to 10. If I shift the graph 1 up, it must go to 1. Good. So now please give me the marker. Where does it go? And I'll plot it. From 2, 1, it goes to, careful, 2, but we're going up 1. Yes, 2, correct. I'm sorry. I thought you said 3. Forgive me. You did say 2. So here it is. So this function is 2, not 2, sorry, e to x minus 2 plus 1. Very good. Very good. Next question, anything else that you wanted to look at?
Of course,
Yes, please, any question?
it's not part of.
Yes, you want to expand that?
Yeah.
Yes, very good, of course. So let's expand. Is this okay with everyone? What is the range of this function? But it has a horizontal asymptote at 1. Exactly. Very good. So we want to expand the following. Natural log of x to the 4th, the square root of x squared plus 3, divided by x plus 3 to the 5th power. Thank you. How many quantities are at the top? I would say factors. How many factors are at the top? Yes. 1, 2. How many factors in the denominator? How many factors in the denominator? Good. So how many quantities will have negative in front and how many quantities will have positive in front?
2 in front and 1.
So say it again.
We have 2 positive and 1 negative.
Correct. So then natural log x to the 4th plus natural log x squared plus 3 with the square root minus natural log x plus 3 to the 5th. Very good. So now we have to address those powers. The power on the first one, where does it go? Very good. Thank you, Reggie. The power for from the second one, where does it go? What power is that? Very good. And the power on the last one? -5, the natural log of x plus 3. Remember, there is no rule for this. Do not try to break up natural log of a sum or a difference. Very good. Next question, please. We have 2 more minutes, 1 more minute or something.
The problem set?
I guess Joseph made it up.
No, I didn't. I was trying to, I think it's, I don't know, but I found it somewhere. I was trying to do it, but I got stuck.
He's the author, so. Is this clear now?
Yeah.
Good. Next question, please.
So this is the end?
There's nothing else. There are no more properties. I applied all possible properties of log. I exhausted all of them. I exhausted the quotient, I exhausted the product, and I exhausted the power. There is nothing else. There are only 3 properties.
Is it gonna be a question like that one?
Yeah, condensing or expanding, yes.
Can I see that?
Yeah, we've done this. So going backwards, when we condense, we have it in equations. Equations ask us to condense, because if we don't condense, we will not be able to solve.
No, one more.
Yes. Ready?
Yeah.
Good.
Ln parenthesis x cubed y all over x plus 1 parenthesis all raised to 1/4.
Right. First, I need to bring 1/4 in front. And then I have 1, 2, 3 quantities. So I have natural log x cubed plus natural log y minus natural log x plus 1. I bring the power down and I distribute 1/4. 3/4 natural log x plus 1/4 natural log y minus 1/4 natural log x plus 1.